Welcome back to the next video of this playlist. In this video, we will mainly discuss the short question of this book exercise given at the end of this chapter. So, first short question is that name several repetitive phenomena occurring in nature which could serve as a reasonable time standard. So, first we should know what is repetitive phenomena. Then we will name these repetitive phenomena. For this, I will be using Scholar series for this purpose. So, the phenomena that repeats after certain intervals of time is called repetitive phenomena. And this short question is important as it is written that it has came it has appeared in many times examination. The phenomena that repeat itself after certain intervals of time is called repetitive phenomena, which could serve as a reasonable time standard. So examples of the repetitive phenomena are lattice vibrations in a crystal, the motion of the rotation of moon around the earth, rotation of earth about its axis, sunrise and sunset, change of weathers. Next one is luminous shadow of a building. This is a repetitive phenomenon. Next short question is that give the drawbacks to use the period of a pendulum as a time standard. Give as the time period of the pendulum is expressed as t is equal to 2 pi under root L over g, but this time period cannot serve as a reasonable time standard due to several reasons. The time period of a single pendulum varies with q and g varies with the altitude. The length of the pendulum may change with temperature in winter or summer. These are the possible reasons for the drawbacks to use the period of a pendulum as standard. Next one is why do we use it? Find it useful to have units for amount of substance, the kilogram and mole. Why there are two units of the amount of substance as kilogram and mole? When we are concerned with the number of particles 1.3, we use the mole as the amount of substance because 1 mole of substance equals to number of particles. N is equal to 6.02 exponent 23. But in case we are concerned quantity of metal, we use the unit kilogram or kg. Next short question is that the three students measured the length of a needle with a scale on which minimum division is 1 mm. So this is the least count and recorded as these three readings, which is correct and why. 0.214, third one is the correct. The correct record is 0.214 because the least count of the scale is 1 mm or 0.001 meter. So length can be precisely measured up to 3 decimals because 0.214 is the correct record. 1 millimeter or 0.001 meter is the least count of the scale, which is approximately up to 3 decimal places. So we should have a quantity which is correct, having a 3 decimal places. Next one is an all student says that a chain is only as strong as the weakest link. What analogy statement can you make regarding experimental data used in the computation? An analogous statement is that a result of experimental data is only as much as accurate as least correct reading in experimental data. So this is the analogous statement of this old saying. Next one is that the period of a pendulum is measured by a stopwatch. What type of errors are possible as we discussed in our previous video? There are two types of error, systematic error and random error. Systematic error, stopwatch may be faulty, zero error may be present or the calibration is incorrect. random error, negligence, and inexperienced person at the time to start or stop the work. Systematic error remains fixed for an estimate while random error changes for the every observation. 1.7 Does a dimensional analysis give any information on constant of proportionality that may appear in algebraic expression? Dimensional analysis does not give any information about the value of the constant of the proportionality but can be determined by experiments. But dimensional analysis can provide the information about the units of the dimensional constant like g, gravitational acceleration, gravitational universal gravitational constant, spring constant, etc. For time period of pendulum t is equal to 2 pi under root L over g. While dimensional analysis provide no information about the constant of 2 pi. Last short question of this chapter, second last, write the dimensions of power and density. Pressure. In order to write the dimensions of the pressure, first we will write P is equal to F4A, we should know its formula. Then we know that force is equal to M dot A. Area is as it is. Writing the dimensions in square bracket M, then LT minus 2 of acceleration. Area having dimensions L square. While solving or simplifying, we will get ML minus 1 T minus 2. Dimensions of density. Density is equal to mass over volume. M is equal to mass capital M dividing the volume by L raised to the power 3. We are given the density dimensions. Next one is the last short question. The wavelength of our wave depends upon the speed of the wave and its frequency. Knowing that lambda dimension of velocity, dimension of frequency, decide which of the following is correct. We will give using these two formulas which one is the correct one. First one is F is equal to V lambda. When we will put the dimensions of left hand side, F is equal to T minus 1 frequency. Dimensions of right hand side, V lambda LT minus 1 into L. So these are not dimensionally correct because left hand side is not equal to right hand side. For F is equal to V over lambda, this is the correct formula. F is equal to T minus 1 dimensions of right hand side, V over lambda LT minus 1 divided by L comes out to be T1. So these are dimensionally correct because left hand side is equal to right hand side. This one has to prove. So in that next video I will solve some numerical problems. That's all from this video.